Okay, so we will move further. So Shikhar asked about the double data type. So once again we will discuss about this. See, in case of real number or floating point number, what happens is, like, if suppose if something like, if it is displayed 5.00, okay. Now if I want more zeros, like 5 point some more zeros, but we should have some limit. That means how many zeros we need, that is a question. So if I want, after decimal point, if I need six places, okay. So let me stop here. Six zeros. For this type of number to store, we can use the keyword float. Okay. Now, if I want still more decimal places, see, when we consider the pi value, 3.1459, something it is there, but it is recurring. Okay. So it keeps on recurring. Infinite value it may go after decimal point. In that case, what happens? We need some more places, like 10 places. So in that case, say after decimal point, if I want 10 places, so if I type 10 zeros, okay. Uh, Now to store this type of value, if we use float, it will not store. That means it will stop at six places only. Okay. So the remaining four zeros will not display. That means four places. Not only zeros, any numbers it will not display. For this, we have to go for the double data type. Okay. The meaning is floating point number only, but after decimal point we need more places to be stored, more values to be stored, either zeros or any numbers. Then we have to go for the double data type. That is the difference here. Okay, but similarity is both are used to store floating point values, that is real numbers. Difference is for float, six places, up to six places we can get it after decimal point. For float we can get it up to 10 places. So from this only we can understand memory will be also different, because six places, that means 10 places is more than the six places, right? So for float data type, we can consider 4 bytes of memory is required. Okay. For double data type, it is more, right? So we require 8 bytes of memory. So 4 bytes means nothing but 32 bits. Okay. Then 8 bytes means 64 bits. You can consider. Okay. So this is the difference. I think I understood. Okay. Actually, we have the examples below. We have the examples, so we discuss. Okay, for int, float, char, and double also we have. Before going to that, so let us consider a brief example. Like, say if I write a value like 25. Okay, so 25 we can consider it as int value. Okay, so float and double have given for character, similar to character constant. So if we consider like any letter, any capital letter, or if we consider any small letter, let me consider m only, small letter m, or if we consider any digit, like if I say 7. See, if you just observe, if I write 7 here, 7 is called as integer, not a character in this case. If you put in single quotes, then it is character. Okay. So for all these values, we can consider it as character. Below values, what I have put, for all this, you can consider it as character. Or any space, any symbol also you can consider. Like if I say plus or dollar or into or star, anything. And if you leave one blank space also, that is also that is put single quotes, press space bar, it will leave one space, then again put single quotes. That blank space is also considered as character. It is not null or it is not empty. For that ASCII value is there for blank space. So this blank space is considered as one value. Okay. So for all these we can consider character data type. Okay. Now when we go for the string, data type is CHR only. Okay, but you have to put in double quotes instead of single quotes. You have to put in double quotes. Either you can consider all of this, like m, small letter m, 7 star blank space, or else more than one word you can consider. For example, if I write a b c, see, more than a b, more than one letter have considered, or else more than one symbol, like dollar percentage. Okay, like this, or only one symbol, like double quotes if you consider star. But you observe in all these examples, either one or more, but in double quotes, not in single quotes. That is the meaning. So only one letter or one symbol you can consider, but in double quotes, or more than one letter or one symbol in double quotes. Even if you consider the blank space also, put double quotes, leave one space, put another double quotes. That blank space is considered as string here. In case of character, it is considered as character. In case of string, it is considered as string. The difference is single quotes and double quotes. Okay. So below examples are there, we will see. So about this table we have discussed right now. Next, coming to the declaration of variables. So coming to the declaration of variables. So as I said here, in all the definitions, int, float, character, and double, I have used the word define. Okay, so define means to store. Okay, what I said is one more word we can use, that is declare. Okay, this word also we can use. The meaning here we will come to know in this particular topic. Okay, for this again we have to go back to the why data type is required. For that we should go back, because these two statements are very very important throughout the chapter. Why data type is required? Because to know the type, to know the amount of memory. Okay, declaration means, like, in general, when I say declare or decide means to plan, to declare. If I say declare holiday tomorrow, the meaning of that is, before we start doing the work, first we have to plan it, first we have to decide. That is the meaning of declaration. So when we declare, what happens? So after that we can do that work. Okay, so here coming to the declaration of variables means, before we start using the variable in a program, first we have to declare, we have to decide what are the things we have to decide: what variable name we are using, and what is its type. See why I'm telling type means, because in variable we are storing values. Okay, so variable means always you understand there we will store the values. Okay, so what data type we have to use, and how much amount of memory it uses. It's the same reason they have given here. The purpose of declaring a variable is to know the type of the data, that means or a value, and to reserve required amount of memory space for a variable. Reserve means to keep some amount of memory for that. The reasons required to data type. The data type is required for the following reasons. Same two reasons they have used for declaration of variables. So why we have to declare a variable? We have to declare a variable. That means we have to plan or decide a variable for this purpose. That is, the purpose of declaring a variable is to know the type of the data or a value, and to reserve. That means we have to keep some memory for that, for value. So when we are storing value in a variable, we have to keep some memory. So for that reason, we require a declaration of variables. Okay, to and to reserve the required amount of memory space for a variable. Okay, here it is there how to declare the variable. Okay, so syntax means it is like formula. I said in mathematics we can consider it as formula. In programming language we can consider it as syntax. Okay, so we will see what is the syntax of this. Syntax to declare a variable. So this is a C language statement. It is C++ statement. Okay, so this is a general thing. So from this we can write the examples. Okay, like in case of mathematics also, when we write the formula, when we use in a problem, in mathematics problems, same variable and same word we need not use, only it should match with the format. That's all. Here also this format you have to consider. Okay, template, we can consider template or format. From this template we can write the examples. So what is the template or formula or syntax? Data type, variable name. So this data type, what is the data? Till now we have discussed what is data type and what are the classifications under. Coming to the variable, so variable is a variable name. Variable or variable name you can consider. So what is that variable? Identifier. So identifier is the name of the variable. Okay, so for variable we have definitions: quantity which changes its value, or the identifier which stores a value, or the name given to the computer memory location. So when we write a variable, you have to remember the identifier rules. So once you remember the identifier rules, you can write variable of your own. Okay, so this is one syntax. Another syntax is also there, that is data type v1, v2, v3, vn. So this v1 to vn are called again variables. So in the first syntax I used only one variable and it is ended with semicolon. In the second syntax I used more than one variable. If you are using more than one variable, it should be separated by commas. Okay, and at the end you have to put the semicolon. So semicolon is there for both the syntax. Okay, difference is in the first syntax we have to use only one variable. In the second syntax we can use more than one variable. So where v1 to vn are called variables, a declaration statement must end with a semicolon. So here we have the examples. See, for all int, float, character, double, we have the example here. Okay, okay. So examples: int I. See, I have taken the variable I just to remember easily. That's all. Because when we write a variable name, so we have to remember the identifier rules, right? So wait for a minute. Okay. So to remember the variable name easily, I have taken first letter of the keyword, that is I. If you write in small letter or capital letter, both are okay. I itself is not a keyword. Int is a keyword. So int I means I is a variable. For float, if you take the variable f, that's fine. For character C, for double D. Or else you can take ABCD, int A, float B, character C, double D. So these are all identifiers. See, first four examples, it will follow the first syntax. If you look at this, data type, variable name. So data type is int or float or character or double. Variable is I, F or C or D. The last example, it follows the second syntax. Data type v1 to vn. So number of variables here separated by comma, A, comma, B, comma, C, comma, D. So this is how we will declare the variables. So once variable is declared, memory is given for these variables. Okay, for I, for F, for C, for D. So how much amount of memory? You go back to data types, you will come to know how much amount of memory. So int occupies 2 or 4 bytes, float occupies 4 bytes, character occupies 1 byte, double occupies 64 bits. Okay, that is 8 bytes. So similarly here, for variable I 2 or 4 bytes, for f 4 bytes, for c 1 byte, for double 8 bytes. And again we have four variables here, a comma b comma c comma d. For each individual variable, for a 2 or 4 bytes, for b 2 or 4, for c 4 2 or 4, for d 2 or 4 bytes, because all belongs to int data type. After this statement, if you want to write the value, I is equals to, so what value you can write here? Okay, small letter I. So what value you can write here? Depending on the data type. So what is data type? Integer. So you can write like data type as sorry, value as 10 or 20, like this, right? Okay, that comes in the next topic, it will come. So these are the examples of data type. Okay, now you can copy this declaration of variables syntax with examples. Okay, we will discuss initialization topic. For this notes you can write it tomorrow. Okay, initialization. See, the meaning of initialization is initial. Initial means starting. Okay, starting point. Okay, so initialization meaning assigning, assigning. That is, assigning is nothing but copying an initial value to a variable in a program is called as initialization. At the time of declaration of variables, we can initialize the values to the variables. See, for example, if I declare the variable like this, declaration. Whenever we write the declaration statement, so we have to follow this syntax. That is data type. Okay, variable. See, throughout the C program, you remember this formula throughout the end of all the chapters because it's very very important. So you have to follow this formula. Give any data type. For example, if I say int a instead of I have taken a. So this statement is called as a declaration statement. So declaration means we are deciding, planning. We are planning to use this variable in a program. So before we plan or before we use this variable, first we have to tell to which data type it belongs. It belongs to int data type. So this is called declaration. Now immediately after this line, if I write like a is equals to 10, okay, that means we are giving some value to a. So at this point also value will be there, but we don't know what value will be there. Compiler will store some value, but when we write a equals to 10, we are sure that we are storing value 10 in a variable a. Okay, so this is at the starting point we are storing the value. See, for example, if I want to do some operation here, like b is equals to a plus 10. So I'm taking this value and again I'm adding 10 to that, or else a equal to a plus 10. So if I tell a equal to a plus 10, so initial value is 10. Afterwards, I'm adding 10 to that variable. That means before you do some operation, either addition, subtraction, multiplication, or division, anything, first you have to give some value for this. That is called initialization. At the starting point, before you do any operation, you give some value for that. That is called initialization. So this is one way of initialization. That is giving a value to the variable at the starting point. Another way is, see, instead of putting semicolon here, so don't put semicolon. Here only you write the value. Int a equals to 10. This is another way. So if you just observe the difference here. First, what we have done, int a semicolon. So we have put semicolon. So this will match with this formula, data type variable. And afterwards you write a equals to 10. Then you can do any operation here. Or else, another way is, before putting semicolon only, you write int a equals to 10. At this point only you write. Then no need of again write a equals to 10 at the next line. I think so. Okay. It is understood that here the value is stored. This type of line is called as initialization. So this is also called initialization only. But what they're telling is, at the time of declaration of variables only, we can initialize the values to the variables. The declaration of at the time of declaration means what? It should follow this line, this syntax it should follow. So it is following int a. If you take out this, if you consider only this statement int a, so int is a data type, a is a variable name. At this point only, if you write the value, that is nothing but storing a value at the time of declaration. In this case, we are not storing the value at the time of declaration. First, we are declaring the variable. Then, in the next line, we are storing the values. In both the cases, value 10 is stored. It's same, but you just observe the difference, the way of writing the statement. Int a semicolon a equals to 10. Int a is equals to 10. Here only we are writing the value. Okay, that is nothing but initialization. At the time of declaration of variable, we can initialize the values. If that is the case, what is the formula? Okay, because formula differs, syntax differs. Here, data type, variable name, semicolon. If you put semicolon, that is the end. Semicolon is always the end of the statement in a C program, not end of the line, end of the statement. Okay. Next, data type, variable. If I put semicolon, it is the end of the statement. But don't put semicolon. Extend that sentence. Data type, variable name equals to value. So after value, you put the semicolon. So if you look at this formula, the syntax. So for this example, it will match. See, I write data type, uh, variable name equal to value. What is data type? Int is a data type. What is variable? A is a variable. Then equals to operator. Then what is the value? 10 is the value. That is the meaning. Okay. But for the first syntax, data type variable int a, you end with semicolon. Okay. So this is the formula to initialize the value of a variable. Okay. If you are not following this formula, this initialization process. First type only you can follow. Put the semicolon. Next line you write a equals to 10. Okay, but this is one way of writing the value to the variable. So okay, syntax data type variable name equal to value. Next, you just compare with this formula. Second syntax data type v1, v2, v3 up to vn. So here I have not given any values. Okay, so in the second syntax of initialization we can give the values. Say for this example I will give you. If I consider this one, v1 is a variable, v2, v3, v4, these are all variables. Value 1, value 2, value 3, value 4. Similarly, so here what I can do is int, say if I write a comma b comma c comma d, that means we are not giving any values, in which include or else. So say int a is equals to 10 comma b is equals to 20 comma, you have to separate it by comma symbol. Okay, 30. Then d equals to n number of variables you can use here. D equals to 40. See, a, b, c, d and variables v1, v2, v3, v4, 10, 20, 30, 40 are the values. So this example is matching with this syntax. v1 equal to value 1, a equals to 10, v2 equals to value 2, b equals to 20, v3 equal to value 3, up to n number of variables. So c equal to 30, d equals to 40. Okay. So this is called initialization of a initialization of variables. Okay. So here I given the memory representation. So this one we can discuss tomorrow. Okay. So on notes also you can take it tomorrow.